Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we discuss two exercises on chapter 2, forms of energy. In first exercise, we have a mini solar cell that is fed a lamp as shown in the adjacent document. In the given of this exercise, we have the energy received from the sun in 1 meter square and it is equal to 500 joule. The surface area of the mini solar cell is 0.02 meter square. And the efficiency of the solar cell is equal to 10%. In first question, we have to name the form of energy stored by the sun. The name of this energy is nuclear energy. The second question asks us, give two advantages and one disadvantage of solar cell. The two advantages of solar cell are free and clean, while the disadvantage is it requires sunlight to generate electricity, so it cannot work at darkness. But there is deep research in the laboratories to improve this problem. In the next question, we have to specify the energy conversion that takes place by the solar cell. The solar cell converts the radiant energy received from the sun to electric energy. What is the difference between solar cell and solar panel? This is the question of number 4. The solar cell is used to produce electricity, so it converts the radiant energy into electric energy, while the solar panel is used to heat water since it converts the radiant energy into thermal energy. The fifth question asks, name the form of the energy lost. It is very simple question. The form of the energy that is lost is the thermal energy. In question 6, we have to show that the energy received by the solar cell is 10 joule. We return back to the given and we have for each second and in 1 meter square, the energy received from the sun is 500 joule. So for 0.02 meter square, how much the energy received by the cell? So it is equal to ER. So ER is equal to 0.02 times 500 and then we get 10 joule in 1 second. In question 7, we have to calculate the energy furnished by the cell in 1 second. The efficiency is defined as the ratio of the energy furnished to the energy received. So the energy furnished is equal to 10% of the energy received, which is correspond to 0.1 times 10, so it is equal to 1 joule in each second. The rated voltage needed by the lamp to operate is 2.5 volts. However, the single solar cell produces a voltage of 0.5 volts. In part 8.1, we have to calculate the intensity of current produced in 1 second. We know that the expression of the electric energy is E equal U times I times T. So I is equal to E divided by U times T. I substitute the values and we get I equal to 2 ampere. In part 8.2, we have to calculate the quantity of charges delivered by this cell in 6 hours. The quantity of charge Q is defined as the product of I times T. We substitute the values, but we have to convert it from hour to second. So I have to multiply by 3,600 and then we get 14,400 coulomb. In part 8.3, we have to calculate the number of cells needed to operate the LED lamp. Then we have to deduce the furnished power in 1 second. The voltage delivered by one cell is 0.5 volts, so we need N cells to deliver 2.5 volts. This N is equal to 2.5 divided by 0.5, so it is equal to 5 cells. The total power furnished is N times the power of a single cell. But the power of a single cell is defined as energy divided by T. So the total power is equal to 5 times energy furnished over time. I substitute the values and I get 5 watt. In second exercise, we have a solar heater that collects solar energy to heat up the water. Recently, the solar water captor is used frequently and usually it is installed at the roof surface of a home. In the given of this exercise, we have the working time of this captor, which is 10 hours per day. The energy received to the earth in 1 second is 600 joule per meter square. The surface area of the captor is 2 meter square. In first question, we have to name the form of the energy received by the captor. So it is the radiant energy. In question 2, we have to specify whether the solar cell or the solar panel is used to heat up the water. For sure, the solar panel is used to heat up the water since it converts the radiant energy into thermal energy, while the solar cell is used to generate electricity. The question 3 asks, calculate the average solar energy received E1 in 1 second. We know that in each second and for a surface area of 1 meter square, the energy received is 600 joule. So in 2 meters square, which is the area of the captor, the energy received is E1. So E1 is equal to 2 times 600, so it is equal to 1200 joule. In question number 4, we have to show that the average solar energy received during 1 day is 4.32 times 10 power 7 joule. We have calculated that the energy received by the captor in 1 second is 1200 joule. So in 10 hours of functioning per day, we receive energy D, or energy per day. Then ED is equal to 10 hours times 1200, but we have to convert it from hour into seconds, so we multiply by 3600 and we get 4.32 times 10 power 7 joule. Knowing that 30% of the energy received by the captor is transferred to water. In question 5.1, we have to show that the energy received by the water is 12.96 times 10 power 6 joule. The efficiency is given by 30%. It is equal to the ratio of the energy furnished to the energy received. In this case, the energy furnished is the energy received by water. So it is equal to 30% of ED. I substitute the values and I get 1.296 times 10 power 7 joule. But it was recommended to write this answer in this form, 12.96 times 10 power 6 joule. So I have to divide by 10 in order to get this number. In part 5.2, we have to calculate the energy received by water in 1 year. So we have to multiply the energy received by 1 day by 365. So the energy in 1 year is equal to 365 times 12.96 times 10 power 6 joule. And we get this very big number. In question 5.3, we have to calculate the energy received in kilowatt hour. So I have to divide the obtained number by 3.6 times 10 power 6, and then I get 1314 kilowatt hour. The cost of a solar heating captor is 10 power 6 Lebanese leaf, or million Lebanese leaf, and we assume this captor function normally for 10 years. On the other hand, the cost of 1 kilowatt hour is 120 Lebanese leaf. In 6.1, we have to determine the cost of the electric energy, supposing that the energy received by the water in 10 years is supplied from the electric main. So first I have to calculate the cost in 1 year, then in 10 years. We know that the cost of 1 kilowatt hour is 120 Lebanese leaf. So how much the cost of 1314 kilowatt hour? So this is the cost in 1 year. So I make the calculation and I get 157,680 Lebanese leaf. and the cost in 10 years, I multiply the obtained number by 10 and I get 1,567,800 Lebanese livres. In the last question, we have to mention which is more economical, the solar captor or the electric. As shown, the price of the solar captor is less than 1,576,800 Lebanese livres. So the solar captor is more economical for 10 years of function. At the end of this video, I recommend from you to resolve these two exercises, and please don't hesitate to ask your teacher for any further information. Wassalamu alaikum wa rahmatullahi wa barakatuh.